Hello everyone. So today we are going to discuss about MPLS. So from now onwards, I'm starting a new series on MPLS and Cisco Catalyst SD-WAN. So today is the first lecture. So today we will learn basic of MPLS. So in my upcoming series, I'll keep uploading the videos on this so that everyone can take benefit on this. Okay. So this is the MPLS multi-protocol label switching. MPLS is a technology uh, which we use. Uh, if we see it as an application, then it is a technology which we use to switch packet from one side to another. So the popular technology is the MPLS VPN. So at first, we will see what is the full form of MPLS. So it is multi-protocol label switching. So when we look into it, multi-protocol, then multi-protocol, it means uh, MPLS allow multiple protocol, multiple types of protocol. So we can if we have Apple Talk or IPX apart from IP also. So we can use in that case also we can use MPLS in our network. So that's why we call it multi-protocol. Okay. So next one is label switching. So what is label switching? So all of you guys have heard about IP switching. So in uh, in every network scenario, we say that IP switching, like when R1 send a packet to R2. So actually, R1 sends an IP packet to R2, and then R2 looks up its routing table and check whether the destination IP address is present in its routing table or not. If it founds, then it sends it to R3. So by looking at the IP address it sends, it takes decision on the basis of IP address. Same way on R3 as well. When R3 will receive packets from R2, then it will check its IP address. If the destination IP present in its routing table, then it will send to here or here based on its routing table. So the decision takes place on the basis of IP packet. So this is called IP switching. Let me take you one example. Suppose that we are applying, we want to ping from site A to suppose that site B. Suppose that, okay. So suppose the IP of this is IP address of this computer is 1.1.1.1. Okay, this is example. And IP of this computer is 2.2.2.2. So now this computer want to send a ping to this computer which is 2.2.2.2. Let me write it here. I want to ping 2.2.2.2. So this computer when I will type ping 2.2.2.2, then this particular computer will encapsulate a packet, will encapsulate a ICMP packet. It is ICMP packet. It is ICMP packet. Okay, ICMP packet will be encapsulated on, it will hand over to L3, which is IP protocol. Then it will encapsulate it into IP packet. Okay. So this is the IP packet. IP packet. So this is the IP packet. Then it will put source IP and destination IP. In source IP, it will put 1.1.1.1, and in destination, it will put 2.2.2.2. Okay, so this is the packet it will generate. Yeah. So this computer has generated, when I type ping 2.2.2.2 on this particular computer, this computer will generate this packet with source IP of 1.1.1.1 and destination IP of 2.2.2.2. Now this computer will send this packet to its nearest to its default gateway, which is R1. Now earlier this packet has this. Now let me resize it to smaller. Okay. Earlier, so this computer has sent this packet to R1. So R1 has received this packet. It will look up its IP packet. It will look up its destination IP address, which is 2.2.2.2. Now R1 will check its routing table whether this route is present in its routing table or not. So if this route is present in its routing table, then it will send this packet to R2. Now R1 has checked that it has 2.2.2.2. Next stop is this R2. Now R1 has sent this packet to R2. Okay. So now R2 will also check its IP packet. R2 will also check IP. R2 will also check its IP header, and it will check the destination IP address, which is 2.2.2.2. Now R2 will check whether this 2.2.2.2 present in its routing table or not. It present in its routing table, then it will send it to R3. R3 will check its IP header that and the route is present. So you see that the destination IP address, which is 2.2.2, during the entire traversal of the packet is never changing. Destination IP address is 2.2.2 here also, R1 also, 2.2.2 here. So the destination IP address is not being changed. But what will happen in MPLS? In MPLS technology, these routers will not will not decapsulate the IP address of any packet. Instead, MPLS uses its own label mechanism with the help of LDP, which we call label distribution protocol. So instead of decapsulating the IP header of each packet, they just swap label. So in case of MPLS, what will happen? Let me tell you. This computer will send this packet to R1. R1 will send this packet to R2. So on R2, what will happen? R2 will insert one label with this packet. Okay, so inserting the label we call as pushing the label, and then it will send this packet to R3. R3 will check the label, and then R3 will swap the label and send the packet to R4. Then R4 will again swap the label and extract the label, and once it reach here, then the label is extracted. So you see what happened here. MPLS label is being applied, is being swapped, is being removed at only ISP end, not elsewhere. This end device never knows what MPLS packet is or what R label. Okay. So now let's understand the terminology. So this cloud is called MPLS cloud. The routers you can see in this MPLS router, all are MPLS router. Okay, all are as ISP router. So R2 router is ISP router, R3 router is ISP router, R4 router is ISP router, and R6 router is ISP router. But we are using MPLS, so we can say this is MPLS router, R2 is MPLS router, R3 is MPLS router, R4 is MPLS router, R6 is MPLS router. But these routers are also used to switch the label. Then we can say this is R2 is LSR, R3 is LSR, R4 is LSR, R6 is LSR. So what is LSR? LSR is level switch router. R2 is level switch router, R3 is level switch router, R4 is level switch router, and R6 is level switch router, because these are being used to switch the label. Okay. Apart from this, R2 is provider router, R3 is provider router, R4 is provider router, R6 is provider router, because these routers are providing services of MPLS to its customers. Now R2 is placed at the edge of the cloud, MPLS cloud. Hence, we will say it as a provider edge router. R4 is also placed at edge of the router, and the customer is directly connected to this router. Hence, we will call it as provider edge router. R6 is also provider edge router. So R2 is provider edge router, R4 is provider edge router, R6 is provider edge router, and R3 is only provider router. So R3 is provider router because no any customer is attached to this R3 router. Hence, it is a provider router. Okay. Provider edge router is connected to this customer router, and this router is placed at the edge of the customer premises, and R1 is directly connected to provider edge router. Hence, we will call it as customer edge router. R1 is customer edge router, R5 is customer edge router, R7 is customer edge router. Okay. So just recall: customer edge router, provider edge router, provider router, provider edge router, provider edge router, customer edge router, customer edge router. MPLS cloud, site A, site B, and site C. Suppose that I have any company. This site is placed at any one location. This site is B is placed at any other location, and this site C is present at any other location. I want to communicate from R1 to R5, and R1 want to send traffic to R5 and R7, and vice versa. So I need any technology which I can use to communicate with each other. So MPLS comes in this as a solution, in this scenario as a solution, MPLS VPN says that with the help of me, you can communicate from R1 to R5, from R1 to R7, and from R7 to R5, and from R5 to R1, and vice versa. Okay. So this is for today. I will upload next video in upcoming session. Okay. Thank you very much. If you have any doubt, you can send your queries over the comment section, or you can send me email to shivam@network@gmail.com. Thank you.